You know, for all of human history, we've used tools to extend our abilities. A hammer for our hand, a car for our feet, a computer for our brain. But what if the tool wasn't something you held? What if it was actually part of you, integrated directly into your consciousness? That's the mind-bending question at the very heart of Neuralink, and its unbelievably ambitious goal to merge the human brain with artificial intelligence.
All right, so here's what we're going to cover in this explainer. First, we'll get into the grand vision of this new human-AI symbiosis. Then we'll dig into the fundamental problem it's trying to solve, something called the brain's great bottleneck. After that, we'll look at the incredible tech, the chip and the robot, see how it led to a mind controlling a computer for the very first time, and then we're going to weigh the huge promise against the very real peril of it all.
So, let's start with the big picture here. This isn't just about a new gadget or some fancy medical device. No, the ambition here is to fundamentally redefine our relationship with technology. We're talking about something that could be a major turning point for our entire species.
So what's the ultimate goal? At its core, it's this: creating a direct, high-bandwidth connection. I mean, think of it like upgrading from a clunky old dial-up modem to fiber optic internet, but for your brain. It's about linking our biological intelligence directly with the massive power of artificial intelligence. And yeah, it sounds like something straight out of science fiction, but it's becoming an engineering reality faster than any of us thought possible.
But why? Why even try to do something so incredibly audacious? Well, to get that, we have to look at a core limitation of the human brain. It's a problem that every single one of us deals with, every single day, whether we realize it or not.
Just think about this for a second. Inside your skull, right now, you're carrying around the most complex object we know of in the entire universe. It's made of, get this, 86 billion neurons, all forming trillions of connections. It's an absolute supercomputer, capable of incredible imagination and creativity. But there's a catch.
And this right here is the problem. Our brains can think at an absolutely blistering pace, the equivalent of thousands of words a minute. But our ability to get those thoughts out into the world, it's painfully slow. We can type it, maybe 40 words a minute if we're quick. We can speak it around 120. This huge gap between our inner world and our outer expression, that is the great bottleneck. And Neuralink's mission is to completely shatter it. So how do you even begin to solve a biological bottleneck like that? Well, you do it with an incredible feat of engineering. Let's break down the two key pieces of hardware that make this whole thing possible.
The technology itself has a name. It's called a brain-computer interface, or BCI, and it does exactly what it says on the tin. It creates a direct communication pathway between your brain activity and a machine. It completely skips the middleman, your hands, your mouth, and goes right to the source of the thought itself.
Okay, so at the very heart of this system is the implant itself, a chip that's about the size of a coin. But it's packed with thousands of tiny little electrodes on these ultra-thin, flexible wires that are actually thinner than a human hair. These electrodes are designed to literally listen in on the electrical signals your neurons are firing and then translate that complex neural language into digital commands, all in real time.
I mean, just stop and think about what that really means. This isn't about voice commands or waving your hands around. This is about pure intention. It's the ability to interact with the entire digital world with the exact same speed and fluidity that you use to form a thought in your head.
Of course, implanting thousands of microscopic threads into a living, breathing brain is, well, it's an impossibly delicate job. There is no human surgeon on Earth with that kind of precision. That's why Neuralink had to build its own neurosurgical robot. First, the machine performs a microscopic scan of the brain. Then, it automatically maps out a safe pathway, carefully avoiding things like blood vessels. And finally, it inserts each and every electrode with pinpoint accuracy. It's a system designed to make the whole procedure safer and way faster than any human hand ever could.
Now, all of this sounds incredible in theory, right? But for years, that's all it was, a theory, an idea. Then in 2024, everything, and I mean everything, changed. Neuralink moved from the lab into the real world, and that marked a pivotal moment in the history of this technology.
The journey from just a concept to an actual reality happened at a truly breathtaking pace. After years of super intense research and development, the massive breakthrough finally came in early 2024. The company announced the very first successful human implant.
And the results? They were nothing short of staggering. The first participant, who was paralyzed, was suddenly able to control a computer cursor, play online games, communicate with people, browse the internet, all of it, with their thoughts alone. This wasn't a simulation. This was a real person controlling real technology, directly with their mind. You have to understand what a fundamental paradigm shift this is.
For all of human history, our interaction with the world has been physical. This event marked the very first time that communication happened through pure, unadulterated intention.
So, whenever you have a breakthrough that's this monumental, the conversation naturally has to get bigger. It has to expand beyond just the tech itself. We have to start considering the future that it's creating, both the incredible utopian potential and the profound, maybe even dystopian risks that come right along with it.
And this really brings us to the central dilemma, doesn't it? We have to balance this immense promise with some pretty profound peril. On one side, you've got this incredible future where we could potentially cure diseases like paralysis and blindness, maybe even enable telepathic communication or enhance our own memory. But on the other side, well, you're opening a Pandora's box of really tough ethical questions about privacy, security, and a new kind of social inequality we've never seen before.
I mean, let's just start with the security questions. They're profound. If your brain is literally connected to a network, what's to stop someone from accessing it? Or even worse, what's to stop them from trying to manipulate your very thoughts?
And what about the data itself? The raw data of your neural signals, the patterns of your thoughts. Does that incredibly personal data belong to you, or does it belong to the company that made the device inside your head? The whole concept of privacy gets a lot more intense.
And then there's the societal question. What happens when some people have access to this technology and others don't? Does it end up creating a new biological class divide? A gap between the enhanced and the non-enhanced? Ultimately, it all boils down to this single, massive question. Are we witnessing the dawn of the next great leap in human evolution where we merge with our own technology to become something more? Or are we opening a door to risks we can't even begin to comprehend? It's a future that is completely uncertain, but one thing's for sure. It's a conversation that we all need to be a part of.